In the second part of this problem, we'll calculate how much time it takes for that 98-mile-per-hour fastball to cross the home plate. And we'll use some of the answers from the first part of the problem that we solved in the previous video. So just to review, we worked out that 98 miles per hour ends up being 44 meters per second. That is the speed at which the baseball is traveling. Now, in a previous problem, we were asked to convert 60.5 feet into meters, and we got 18.445 meters. And the reason we were asked to do that in a previous problem or example is because that is the distance from home plate to the pitcher's mound on a baseball diamond. So that's some background information that we'll use, in addition to the fact that we'll use this equation where v without a vector hat, so not velocity, it just stands for the scalar or the magnitude component of velocity, which is speed. So speed is equal to the distance traveled divided by the time it takes to travel that distance. So using the information we have available, let's write down what is known and what we need. So we know from our previous work that the magnitude of the velocity of the baseball is 44 meters per second. So that is equal to the speed. We also know from a previous problem that 60.5 feet is equal to 18.4 meters. That is the distance that the baseball travels, and we're asked to find the time it takes to travel that distance. So what we'll need to do is use our speed equals distance divided by time equation and solve it for the variable that we need, which is t. So doing some algebraic rearrangement of the equation, we have v equals d divided by t. And the algebra tells us to multiply both sides of this equation by the variable t. So we'll get v times t equals d. And since we're trying to isolate or solve for t, we need to now divide both sides of this equation by v. So we'll get t is equal to d divided by v. And let's translate that back into words. What we have is the time it takes for the baseball to travel this distance is equal to the distance divided by the speed. So now that we've got that, let's go ahead and plug in the numbers that we're given, that we know. And so time is equal to the distance, which is 18.4 meters, divided by the speed, which is 44 meters per second. Now I want you to notice something here, which is that we're going to end up dividing meters by meters, and so the meters are going to cancel out, and we're going to end up with seconds in the denominator of the denominator, which is going to flip the seconds up to the numerator. So we're going to end up with the seconds, which is what we need. So when we say follow the units, it means the units that we get in our answer should be consistent with the problem throughout. So let's go ahead and divide 18.4 divided by 44, and that gives us 0.41818, repeating, so 0.41818, and it's time and it's seconds. So now that we've got an answer, let's decide what to do about significant digits. Well, in multiplying and dividing, the rules are going to tell us to round this to 2 digits. So let's say time is equal to 0.42 seconds. So when we go and write a therefore statement, it's going to say, therefore, the baseball takes 0.42 seconds to go from pitcher's mound to home plate. Okay.